Hello and welcome to this episode of the AI Show. It says starting soon, but it lies. We're starting right now. Hello and welcome everybody again. This is another episode of the AI Show live, coming to you every Monday at 8:30 a.m. Pacific time. It's early for us, but that's okay because we want everyone to participate around the world. We'll start with where's everybody coming from? Tell us where you're coming from. We want for you to participate and be part of the show. If you don't mind, we would love that. Today we've got a great show for you. In fact, let's go to the whiteboard here. Blackboard. We'll start writing what we got going on today. Oh, I have like a real pen. That's going to totally ruin my Wacom tablet. We can't do that. Can't do that. But today, we have a good show for you. We're going to be talking about Responsible AI Mitigations and Tracker. Responsible AI Mitigations and Tracker with my friends Marah and Besmira. You may, if you've watched the show, you may have seen Besmira. She's a lot smarter than I am. But don't tell her I said that. Or maybe you should. I don't know. And Marah built a wonderful demo that we're going to be looking at. Then I thought what we would do if we have some time. I was thinking we would go back to our Rochambeau project, or we would look at my GPT project that I wrote. Maybe. It depends on what you want to do. Really. Because this show is for you. All right, let's take a look at the chat. Where is everybody coming from? From Mexico. My mom's from Mexico, but not La Ciudad de Mexico. She's from Culiacán, Sinaloa. Oh, I feel like I need to say it like monster truck style. Culiacán, Sinaloa. I mean, yeah. Yeah. Maybe I'll turn that part off. Portugal, welcome. Turn that little reverb off. I've never been to Portugal, but I did live in Spain, southern Spain for a while, and I had a really nice friend from Portugal. In fact, all of my friends are in Portugal too, because I am friends with everybody. Jay McCormick, welcome, my friend. Sorry we mixed up the times for you last time. Now we've got it all sorted out. We found that Monday mornings work because like people are starting to wake up to the week and it's like, And so a good Monday morning pick me up with AI we thought would be wonderful. Auburn, Washington, welcome. Just a little south of me, indeed. I live in a little small town close to Redmond, where Microsoft headquarters are. Redmond's a little town too. Seattle's the big city. GPT for the win. GPT FTW. It's like we decided in tech that we had to make so many acronyms. You can't even see my face. What am I doing? We decided in tech that we had to do so many acronyms for stuff. We should just leave that up there. GPT for the win. India, welcome, my friend. Lovely to have you here. We have someone from Greece. I've always wanted to go there. It's like hang out in Mykonos or something. I've taken enough math to know almost half the Greek alphabet. So just FYI, I can almost read it. We have someone from Kenya, delightful place. From the UK, Hawaii. Oh, is that hi or Hawaii? I think they're all cool. Welcome again. It's a pleasure to be with every one of you. Again, we're going to be talking about responsible AI mitigations and tracker, how to do stuff to make things a little bit more reliable when it comes to responsible AI. Okay, so let's bring up our guests here. We have our guests here. I know Marah's here. Hi, Marah. How are
Hi.
you?
Good. How are you this morning?
Fantastic. Besmira. Oh, Besmira's here too. Hi, Besmira. How are you?
Great.
You good? Oh, Are you getting your audio working?
Yes.
Oh, see,
It
it works. It works.
does. It does.
I'm so glad you're here to educate us, my friends. What we're going to be doing again is we're going to be talking about the responsible AI mitigation and tracker with Besmira and Marah. But we pre-recorded this the other day so that we could get we can get the technical stuff out. And then are you okay staying after and answering questions?
Of course.
Those of you in the chat, please get your questions ready. Again, we recorded a little bit of this chat. This is all actually live. See, look, we wouldn't do this in normal videos. See, yeah, there you go. We're actually here. But we did pre-record the other part because that part goes into our official Microsoft things, and so we have to like be kind of serious. It's awful. Like it's awful. Like I couldn't get them to stop swearing on the video. I'm just kidding. They're so nice. All right, so let's do this. Let's get the video going and let's play it now. And as you have questions, please make sure to get them out. Let's take a look at this. Responsible AI mitigations and tracker coming to you right now. You're not going to want to miss this episode of the AI Show where we talk all about the responsible AI mitigation and tracker. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about the responsible AI mitigations and tracker with my good friends, Besmira and Marah. How you doing, my friends?
Great. Thanks for having us, Seth.
Fantastic. So why don't you introduce yourselves? We'll start with you, Besmira.
Hi, I'm Besmira. I'm a researcher in Microsoft Research. I work on tools for responsible AI.
Fantastic. Marah.
Hi, I'm Marah. I'm a research engineer. I work in Microsoft Research, and I love all things machine learning.
Me too. We're on the right show. So let's start first with the obvious question, at least for me, and we'll go to you, Besmira. What does it mean to be responsible with AI?
Thanks for asking that, Seth. There's so many definitions of what does it mean to be responsible. I'll give an unconventional definition today that is perhaps closer to machine learning engineering. With this toolbox and the new tools, what we're saying is that to be responsible means to be careful in your day-to-day engineering steps. It means that you should be able to identify your errors in a streamlined fashion. It means that you'd be able to diagnose why those errors are happening. And it also means that you take an informed decision and not just like a trial and error approach when you try to mitigate those errors. And all things considered, responsible, it also means that you need to validate all the actions that have been taken in this life cycle.
So, I mean, that's an awesome definition, but it feels like there's like some extra work you have to do and there's some tooling or whatever. How does someone begin to start to do that, to build machine learning models responsibly?
Yeah, so no surprises there. All these things that I mentioned, they are easier said than done. When it comes to implementing them in practice, it's a lot of work. It's a lot of code that you need to write from scratch for every project. What we're doing with Responsible AI Toolbox is trying to accelerate all of these processes and build tools that can help engineers do this in their day-to-day work and hopefully, get faster results without doing a lot of the trial and error that unfortunately we still have to do with
All right, so that sounds awesome. I feel like, Marah, can you show us how this is done?
Yes, today I'm going to give you a demo of this. Okay, so what you see here in today's demo, I'm going to show you how we can combine our 3 responsible AI tools And so what you're looking at here is a JupyterLab environment where I've already installed our JupyterLab extension, RAI Tracker, our first tool of the day. So a little bit about RAI Tracker. It's a tool to help you compare, visualize, and validate different model experiments and improvements. So, and by the way, you can install it yourself very easily with a simple pip install.
Ooh.
So let's jump right in here. I have my first notebook, which I've already imported, my baseline notebook. Okay, in this notebook, I'm loading the UCI income dataset, and I'm training a light GBM classifier for a binary classification where if the individual in the dataset has, for your reference, an income higher than or equal to 50K, then it's a positive label, otherwise it's a negative label. So before training my model, I am doing a little bit of data pre-processing. So using our second tool, the RAI Mitigations library. And a little bit about it, it's a Python library. Again, you can install it with a simple pip. And it offers what we call a non-fragmented experience, where you can improve the data in a way that improves the performance on the model. And so you'll see multiple ways of how to use this library throughout the demo, but here it's very simple. We're just using it for an imputation and encoding pipeline before training the model. And then simply I just train, save the model, and then what I do is I register it in RAI Tracker. And I've already registered it here, but I'll show you a little bit what the interface looks like. We have our model, but along with the model, we have a test data set that the tracker can use to evaluate the model throughout these experiments. Okay.
Can I ask a couple questions?
Yes.
So the first question is, this pipeline, is that like a scikit-learn pipeline, or is that pipeline like something from the RAI toolbox?
The one I'm using here, it is a scikit-learn pipeline.
Perfect.
Yes,
Perfect.
but every mitigation within the pipeline I'm using is from the RAI mitigations library.
I see. So the data, for example, the one-hot encoding, I'm guessing, is what the encoder is doing. Is that something that's in the mitigations library to be able to understand what's happening as it's going in? So that was the first question. The second question is, you clicked on something inside of the Jupyter Notebook that showed a model thing. Is that part of the RAI tracker as well? Do you know what I'm talking about?
Yeah. So I'm guessing you're talking about
Yes,
this.
exactly.
This is part of the tracker. This is part of the tracker interface. I've already registered the model, but here you will see a little register word that says register. You click on it, and then you can upload your model. You choose the platform, and then you choose whatever data set you want to evaluate it on. This is all part of the tracker interface, and it's clean. It's easy for the user to use.
And this you would do after you train, like, for example, this light GBM model with the pipeline.
Correct.
Got it. Okay, cool. I understand.
So in the back end, I've saved it and then I've registered it. Correct.
Fantastic.
Okay. So we'll look a little bit more about the accuracies and the metrics of this model in a little bit. But before, I want to take a closer look at the data itself. So, and that's where our third and final tool, which we've talked about here on the show, but it's the Responsible AI dashboard. I'm just going to remind you of what it is. So here I'm using the RAI widgets Python library. I'm propagating the widget, and I've opened it here. And the first thing here we see is an error analysis tree. So we can see an 18 or 19% error rate, which matches our 81% accuracy here. But if we look at the data itself, not just overall, but for specific cohorts such as this one, we see a bit of a full circle, which indicating there's more errors. For this cohort here, it's for individuals whose relationship is husband or wife. So let's say they're married individuals, right? So if we have almost a little more than 35% error rate compared to the non-married individuals with only a little more than 5% error rate. So that's quite a big difference, right? And it could be part of the reason why something we can mitigate and improve in the model. So to do that, I'm just going to take another look here at something in the label distribution. Okay, so we have our full data. We can see there's a skewness here towards the negative label. There are less positive labels than negative labels. But what about the cohorts that we saw just up there? And mind you, here I've already created these cohorts, but using this button right here, and You can very easily create any cohorts you like, combining different aspects of the data. But here we have on the merit cohort, what we noticed is there's a bit more of a balance, right, compared to the full data. And let's just keep that information in mind as we move forward with our experimentation. And before moving on, I'm just going to look at the not merit cohort.
Ooh.
We see a bit more similar to the full data. Again, we see the skewness towards the negative label. So now that we know this information, let's go back to the tracker and try to build on top of that to mitigate some of these issues and improve the model itself. Okay, so I've already imported my second notebook, same data set, also like GPM classifier. But what I'm doing here before doing the pre-processing and training the model, I'm using an extra mitigation here. Again, from our library, from the RI mitigations library, using the rebalancing mitigation to rebalance the full data. And here I'm using an oversampling strategy where we're just sampling enough data points to create a balance between the two classes for the full data set. And so the same thing here, I get my new X and Y after resampling, the same pipeline, and then save the model again. And then, of course, I have to register it. Mind you that I'm using the same data set, the same test data set, because I would like to compare the two. And of course, here, we can look at the accuracy. There's some improvement. But before getting there, what I want to see, again, I want to look at this label distribution post-rebalancing. And I'm going to do that here within my notebook very easily, using one of my favorite parts of our RI mitigations library, and that's the cohort manager. The cohort manager class, it lets you do what we did in the widget where we created or looked at these cohort within your Python code very easily. You don't have to do it. You don't have to do it manually. You just give it the filters that you'd like to add for your cohorts, and then using a transformation pipeline, we can simply create these cohorts and look at the distribution, plot the distribution for both of them. Okay, so here we have our full data. Obviously, we did a rebalancing over full data, so as expected, we have a very balanced full data set. But if we look at the merit cohorts, we can see there's a bit more imbalance than before. And that's because we have a lot more positive labels now. And that's probably because in the beginning, most of the positive labels were in the merit cohorts. And so after the rebalancing, they came from the merit cohort. Compared to the not merit cohort, that's still very much imbalanced. Okay, so what we can do here, now that we have all this information, we can compare our baseline to this new model. And now that I've registered both of them, I can click on this compare models button here, and I will get this tab where I can see a visualization of this comparison. So I've selected both the baseline and this new notebook. And looking at the accuracy, we see some improvement, right? But mind you, there seems to be quite a bit of drop in the precision. But why is that? Let's look at the cohorts again. We can create the cohorts within the RI tracker itself, not just in the mitigations library or the widgets, but again, all these tools are meant to work together. They're meant to be compatible. So I've created here already are the merit and not merit cohorts. Again, similar to like in the widget in the library. So I'm going to add them in for a more detailed look. Let's start with the baseline. You can see that the not merit cohort already has quite a decent performance in the first place. The merit cohort post rebalancing, the merit cohort seems to have improved in accuracy, but again, we see this drop in precision and not much change for the not merit cohort. So this really gets us thinking, if this is the case, why don't we try a more targeted approach where we can simply focus on the merit cohort? And since the not merit cohort already has decent performance, why don't we just leave it as it is? And again, this could help because most of the positive labels were sampled from merit cohort. This could really be what's hurting the precision. So given that, our final notebook here, which
let's pause right there just so I can ask a question. So the first rebalance, you're basically rebalancing based upon the label. Is that right?
Correct. I'm rebalancing the full data set based upon the labels. Correct. I want an equal number of positive and negative labels for the full data.
I see. And when you do that, does the data set get smaller, or do you resample multiple times to make the data set the same size-ish?
You can, so given an oversampling strategy, we synthesize some new data sets, some new data points, if that makes sense.
That makes sense. And so when you were, because the first thing we noticed is that there was an imbalance in the label.
Mm-hmm.
We rebalanced the label, and when we rebalanced the label, we noticed that we were having some precision problems in another cohort of data because there was an imbalance in that particular feature as well. Am I getting this right?
Yes, and because we did the rebalance over the full data, it couldn't, it wasn't targeted towards specific cohorts, so it didn't know where to add new positive labels or not to add new positive labels. So that makes sense. So it was a very blanket approach, and so it didn't give us, that's why it hurt our precisions for the merit cohort, for example.
And that makes sense because the married not married, there was an imbalance there to start, and when we oversampled, we kind of kept that. We oversampled, balanced one label, but it didn't cause the other one to fix. And so now we're going to go look and see how we can fix that particular problem. Okay, makes sense.
Correct.
Let's do it.
Okay, so our last notebook here. All right, so what I want to do here, I want to focus on the merit cohort. So again, using our cohort manager class, we can create the cohorts very nicely. And this time I'm not just using the cohort manager just to plot the label distribution, but rather I'm using it to train to fit two different transformation pipelines. And so our first pipeline you can see here has a rebalancing mitigation, but the second pipeline is empty right now. So after transforming the two cohorts, I resample, I get my new X and Y. And this way, the not merit cohort, as we said, Seth, it's untouched. I did not do anything to it. So post this, I can do over the new X and Y, I do the same pipeline and the same estimator, save my model, and register it, of course. And before looking at the comparison, back to our tab here, let's do the same thing and look at the new label distribution. So we see over the full data set, a bit more balanced than before. However, the merit cohorts are perfectly balanced, and the not merit cohorts have not been affected by the rebalance specifically. Right. And that was our goal in the first place, right? So let's see how that looks like in the comparison tab. Okay, so of course I've registered the model with the same data, with the same test set, and I'm going to add it in right here. Okay. So over the full data, we see a 4% improvement in the accuracy. That's pretty nice. That's better than before. For the merit cohort, a 9% improvement in the accuracy. Again, that's even better than before. That's great. But as expected, the not merit cohort has not been affected. But more importantly, what I think is the most positive outcome of this is that the precision was not as hurt. We have a lower hit in the precision. And this, again, the benefit of this more targeted approach where we focus on the cohorts that need our improvement rather than just a blanket mitigation. And so this is basically how we use these tools together to iteratively build and improve our models in a way that tells the full story.
And that's pretty cool because it's like you're basically doing data science over a single model, but you're working on the data. Usually when I'm doing this stuff, I'm like just trying different models to get better accuracy, but it's more nuanced than that because you also have to look at the data. Is that what I'm getting from this, Besmira?
Yeah, that is a very nice way to phrase it, Seth. Basically, we're coming here from another end, which is like the data end. And since we're all doing like data science, machine learning models are trained with data, good quality data transfers to good models. And it's something that perhaps we have overlooked a little bit in machine learning, and we need to go back and put more emphasis in that end.
And I absolutely love that because I always tell people that machine learning is just a lazy way of writing functions with data. But if your data isn't good and you can't look at it in an analytical way, you're kind of not being responsible, right?
Yeah, you cannot always hope for the best.
That's true. So let's talk about this. Where can people go to find out more, Besmira?
Yeah, so a couple of things. We wrote an end-to-end blog post that puts all these three tools together, the dashboard, the mitigations library, and tracker. And obviously the GitHub repositories, everything is connected in the Responsible AI Toolbox repositories. Everything comes with a dash name GitHub repository, and you'll be able to find them under the Microsoft org.
Well, this has been delightful. Thank you so much, Marah, and thank you so much, Besmira.
Thank you.
Thank you for
Thanks.
having us. Yes.
Awesome. We've been learning all about responsible AI mitigation and tracker with Besmira and Marah. Thank you so much for watching, and hopefully we'll see you next time. Take care. How about them apples? Such a good job. That was really cool because like I said, I always thought like if I fix some parameters here and there in my model or some hyperparameters, I'll make it better. But looking at the data end of it is actually quite cool.
Mm-hmm.
All right, so there were some questions here from folks that I want to make sure we get out there. Hi, oh, here we go. And you kind of mentioned some of these in the chat, but I thought we'd talk about them. C# library is available, or any wrapper for C#. This is from our friend Sharafuddin.
Unfortunately, the quick answer is no. We don't really have C# because Python tends to be very popular with data scientists and has a lot of wide range of tools that are good for training models, for tabular data. So Python is a good choice for us. But like I said in the chat, keep in mind that you can always build the models themselves within our environments, within our tools in Python, and mitigate them, build them responsibly, and then you can always use them in your C# environment as plain models.
Yeah, and that's true. Like generally, I have found that the workflow. I mean, this is just me, maybe, and I'm a .NET dev. I was a .NET dev for like a decade and stuff, and so, but generally, I've found the pipeline to be all Python until you have a good model, and then that model is either put into a REST endpoint or consumed directly using Onyx or something, right?
That's true, because C# is more common for application use, building SDKs, etc., rather than building models. At least in my experience. But there you go.
I love it. Here's another question: can it integrate with Visual Studio Enterprise? And my sense is that Simon's doing stuff in Python. As I looked at he's like, "Hey, I'm doing stuff in Python."
Mm-hmm.
I mean, if you can do Python stuff in Visual Studio, then can you use this stuff, Besmira?
Yeah, certainly you can just import our AI mitigations library just as any other library and use it in Visual Studio Enterprise. For Tracker, the story is a little bit different because it's built as a plugin in JupyterLab. And for that, you'd have to download the models and import them into JupyterLab, basically Tracker, and compare them there. But keep in mind that as we do this work open source, we're also part of the Azure machine learning team basically, and a lot of the innovations that you see here do come in Azure machine learning pretty quickly, such as the dashboard, for instance. And there have been several sessions here with Minsu and Mernush showing how this works on Azure machine learning.
Correct. And this is, I don't think people realize, but a lot of this stuff is like really new. And y'all are in the research department, and you're like, here's this cool thing, and we're like, well, we don't mind if we do, and then we put it into our products as quickly as we can, and that's generally the way we do it. But we want everyone to participate in this goodness, and that's why you do it open source. Or is there another reason? Can you tell us why we kind of research open source and then in our products? Besmira, do you have thoughts on that?
Yeah, I mean, we want to be at the forefront of innovation, basically, and put out every innovation that comes from research and have people participate. And because we talk about responsible AI here, transparency is like one of the main things that we want to promote, and have a participatory design in the new tools that we're building. Another aspect of this is education and research. We have a lot of folks that basically use the tools to teach machine learning in a responsible manner. And because if you spin them off in like Jupyter widgets or in these like tools that do not need like a lot of integration at the beginning, then it's easier to teach the students. And then slowly you take them in and you show them, well, here is another larger ecosystem that you can bring the tools in.
I see. So it's twofold. It's one for openness, because if you are going to do something responsibly, there should be some transparency. And the second is because the reason why you made certain choices so that it becomes more widely available to people that are studying this stuff. Did
Yeah,
I get that right?
yeah, yeah.
Okay. Looking at, here's Janice, who number 7. He's saying very responsible AI, of course. Now, when people are thinking about being responsible with AI, there's got to be like what's your rule of thumb for like what should my mindset be before I do anything with machine learning AI, whether it be with large language models or the small models, any model. How do you think about this? Like, how should I think about this?
There are several aspects of this, and there has been a little bit of a paradigm shift in how we do machine learning between when we started, so to say, in like the 80s, and now. There used to be a little bit more focus into understanding the data before you bring it into a model, and curate it, and basically just produce graphs that allow you to understand the data better before you bring it in the model. But then the data became large, like we're talking now about bringing in like a whole amount from the internet into models. And with that, it felt like this is more difficult. But the truth is that no effort goes wasted when it comes to understanding the data, whether it is about the quality of the model or about understanding potential threats that may be there existing in the data. And once you see them, you cannot unsee them again.
Mhm.
Yeah.
And this is like one very particular thing that I'd like to mention before you even like go and build a model. And Marah as an engineer may have a lot more.
Mara, what do you think?
I totally agree. I think regardless of and when you say responsible AI sets, people tend to think it's about sensitive data or personal data. When that or like when that comes into play, that's when it matters more. And it does matter very much in those cases, but it also matters all the time to just really take a closer look at your data. In fact, whether you're building a model that's going to do a very simple task that is absolutely can never be problematic or not, it's still good to look at your data, to plot it, to look at different cohorts, to compare if you're just a classification problem, to compare, similar to what we did in the demo, to compare label distributions, to just take a closer look. And like Besmira said, it's never wasted. An experience, I will tell you, it's never wasted, regardless of what you're doing. It will always help you, whether build a better model with more accurate or just more responsible model in general. Absolutely.
Well, that is delightful. Here are some links, by the way, if you saw them in the show. This is if you want to go to the Responsible AI Mitigation and Tracker. This is the blog post that you can take a look at these things. And then here are the GitHub links where you can actually look at the mitigations as well as the tracker. My friends, thanks for being with us.
Thank you for having
Thanks
us.
again, Seth.
We'll see you next time, Marah. We'll see you next time, Besmira. How about them apples? That was cool. I always like learning about this stuff. Being responsible is tough. It is tough. All right, my friends, it's time to go to our projects here. We have about a half hour left, and next week we have a doozy of a show. By the way, I'll tell you a little bit about that. So maybe we'll put our GPT project. We'll do that maybe next week because it's gonna work out with what we're talking about. It's pretty cool. So, yeah. All right, so let's get to our project here. I'm trying to remember where we left off. File open recent Rochambeau. Rochambeau. If you remember, this project, Yarn Dev, is I forgot to go to the web. LS. Here we go. Just to remind you of what it is that we're building, we'll move this over here. We are choosing this webcam number 2. Hello. And then I hit submit. Oh, scissors. I have a scissor face. How dare you? Cheap machine learning model. None This is a crappy model. I think I know why it's a crappy model, though. I think I trained it for one epoch and then put it in, which was not good. And so we decided that in order for this to get better, is that we would have to train it by giving it images. So we did this training thing. And now notice that I can press the space bar, I think. Oh, no, that's not it. Press the space bar and it captures some nunnies, some scissors. Wait, what? Oh my gosh. There's something else here. Did you see what happened? Oh my gosh. We are so bad at this. So now when I hit scissors, let's see, spacebar, scissors. But if I go to paper and put a paper out there, I think we have to do something there because that's not working. But again, that's what we're doing. We're going to be building an interactive rock, paper, scissors project where everyone, will be able to go and play rock, paper, scissors with each other live. But we got to make sure that, like, for example, because the models kind of suck right now because I trained it just on my face. That we got to make it so that everyone can have their own model so that it's accurately representing the thing. And so we're trying to build an ML ops sort of end-to-end, get more data, etc. And that's what this is. And so I'm trying to make it so that it's easy to capture, so that when you press the space bar, it'll just take images of you like once a second and once every half second. But we got to make it so that it doesn't get confused. Because now, look, it says paper. So there's like an off by one issue going on here, and we got to figure out what that is. Okay. Oh yeah, and we had a really interesting. Remember, we had this learning that by val versus by ref, and that was what was happening with our array. It was just getting all mussed up. Okay. Okay. Now we need to handle the changing of this thing. So we also need to make sure that anytime the label changes, it also affects the adding of the thing. And so that would be in the use effect. We would have to change this. That's what's happening. What the heck? Oh, it looks like Tailwind changed. So that's how we fix that. I think. Let's refresh. Okay. We're gonna do some nunnies. One. Oops. None. Yeah. See that? We're so smart. Yeah, what happened was, because I didn't add this as a dependency, when it changed, it did not like use effectify everything. So yeah. Now it works. Okay, now what we want to do is we want to make it capture images every half second. So, do we use this handle key? Yeah, we do. We do that here. I think what we should do here is start the process of adding an image. And okay. Set timeout. I think it's the set timeout. Set timeout JavaScript. What do we got going on? Tell us, Mosey. The global set timeout method sets a timer which executes a function or a specified piece of code once the timer expires. I don't think we want timeout. I think we want the other one. Web APIs. There's set timeout, but there's another one. Set interval. Set interval. Let's see if we can find it. Set in. There it is. I knew it. The set interval method offered on the window and worker interfaces repeatedly calls a function or executes a code with a fixed time delay between each call. This method returns an ID, an interval ID, which uniquely identifies the interval. So you can remove it later by calling clear interval. Okay. But then how do you do that in React? Set interval, set, because there's like some crazy like state thing. Interval. Set interval in React app. Stack Overflow. Oh, before we go, I also got to tell you, soft announce something. That's okay. I almost forgot. I'm still very new about it. I've been going on slowly. I'm kind of something I'm stuck on. I'm trying to build a timer component in React. And to be honest, I don't know if I'm doing this right or efficiently. In my code below, I set the return object current count, and I've been toying with blah, blah, blah. Okay. Get init. Component did mount set interval. Component will unmount clear interval. Timer function set state. I see 4 issues with your code. In your timer method, you are always setting your current count to 10. You try to update the state in render method. You do not use set state method to actually change the state. You are not storing your interval ID in the state. Oh, I see. Okay, so okay, so we need to have an interval ID, and we need to set the state of it. Okay, let's see what we got going on here. So let's try some code. Const interval. Use ref. Why is it telling me to do that? What is this? There's a set intermediate. What is this? I don't even. Wow, there's so many things I'm learning here. JavaScript. You sly dog been holding out on us this whole time. Let's see. What is set? What's that? Oh, this is like a do something, but this is like the async way of doing something in this case. Interesting. So let's go back here. No, what did we set interval here? Code delay and then the args. What are the args? We don't want that. Delay. Additional arguments which are passed through to the function specify func once the timer expires. The return interval ID is a numeric non-zero value which identifies time period. Okay. Wait. Let's go back over here. But it let's see. Use ref set interval. With use ref, we can create and update single mutable value that exists for the lifetime of the component instance. After assigning the ref to a variable, we use current to access blah blah blah. In this example, we store the return value of set interval, which is interval ID, so that we can later call clear interval. This is cool because what happens is instead of setting the state, we can have a mutable version of interval. Oh, look at this. Diamond DD. This is the real deal when someone is programming. Amen. Oh, yeah. Yeah, I've been programming since I was 16. I'm like 40 something, 43 right now. So how long is that? 16. 43 minus 16. Holy cow. Maybe take a couple of years off when I wasn't programming. I don't know. I was 2 years. I've been programming for 25 years. I still gotta look crap up. Everyone keeps inventing stuff. You know, what are we supposed to do? You keep inventing stuff. So I'm thinking we'll use an interval ref for 450 years later. Me and Janice Q number 7 are gonna find a way to get a cybernetic implanter, and we're still gonna be looking on Stack Overflow to get crap done. There's just no way to do it. Okay. Okay, let's use a ref for the interval ref. So we'll do const interval f equals, and I don't know if I like timeout. Interval, is there an interval? Interval ref. Hold on, let's go back to it. It had timeout. Interface timeout. What other interfaces do we have? What do we got going on? Global. There's a timeout. Was there a timer and an immediate and a timeout? Timer. Let's try it. Oops. I closed it up. Use ref timeout. Interval ref. And what we're going to do is anytime the space button is hit, right? We're going to set an interval. Set interval. Hold on, let's go back over here. There you go. We'll do this. We'll say blop. We'll say if use what's the ref? Interval ref? Interval ref dot current means that there is one. We're going to clear it. Clear interval. Boop. And that's it. Else, what we're going to say is look at that. It's like it knows. Oh, sorry. I'm Python. Oopsies. If interval ref dot current, clear interval, and then we can say interval ref equals undefined. Boom. What do you think? I think 100 milliseconds is too fast. That's like a tenth of a second. So let's do 500 millis. 500 millis. All right, let's see what we got going on here. Refreshos. Oops. And then we go here. And then I'm just going to do some nunnies. Oh, shoot. None. Uh-oh. Do you see this? You see what's happening? I see it too. I see it too. We might also need to add the interval ref here. Oh, whoops. Maybe. Maybe? No, because it'll add the Oh my gosh, this is just crazy. Why? We are really learning the guts of React. So we have the handle key. Add image. Is it? I know why it's happening. Gosh dang it. What's happening is every time I add something to the images, why is my screen doing that weird thing? Anytime I add something to the images, this use ref gets this use effect gets called again. And what it does is it adds a key event listener, which if there is one interval ref, it clears it and then sets it again. And so it's just like can't figure it out. Gosh, I remember writing this. I wrote this a long time ago in regular JavaScript. And for the love of all that is holy, it was so much easier because I didn't have to worry about the state of all the other things. Let's see here. Yeah, this is rough. I've got to find a way to manage state better here because this is untenable. Because it looks like it use affects this thing, which makes sense. Let's take a look at use effect and see what's going on here. No, I don't want a medium thing. Give me the actual docs. There you go. Use effect reactor lets you synchronize a component with an external system. The function with your effects lock setup. It's right here. This is setup, and then this is it returns the thing to do when it's done. Your setup function may also optionally return a cleanup function. When your component is first loaded to the DOM, React will run your setup function. After every re-render with changed dependencies, React will run the cleanup first with the old values, and then run your setup function with the new values. After your component is removed from the DOM, React will run your cleanup function one last time. The list of all reactive values referenced inside the code. Reactive values include props, state, and other variables declared inside your component body. If your linter is configured for React, it will verify that every reactive value is correctly specified as a dependency. Use effects a hook, so you can only call it topic component. If you're not trying to synchronize with some external system, you probably don't need an effect. Interesting. So then what are we doing then? Why am I doing it wrong? When strictly will run one extra development setup plus cleanup cycle before the first real setup. This is the stress test. If some of your dependencies are objects or functions defined inside the component, there's a risk that they will cause the effect to rerun more often than is needed. To fix this, remove unnecessary object and function dependencies. You can also extract state updates and non-reactive logic outside of your effect. What does that mean? When you want to update state based on a previous state from an effect, you might run into a problem. I'm running into a problem. This is literally what's happening to us here. Since count is, this is literally what's happening to us. Except for us, it's images. And then this thing calls a function which calls set interval. We're running out of time. Get our walk-off music on. So yeah, that's fun. Oh, it's how they fix it. It says reactive, blah blah blah. Now, okay, here we go. Let's remove unnecessary objects. Yeah, it basically resets the whole thing every time. What a bummer. All I can say in my head is this. That's what's going on in my head. Thank you for listening. Yeah, so thank you for this. Oh, here we go. Here's the answer. Oh, yes. Yes, sorry. Oh my gosh, I totally forgot. So, let's go to GitHub communities here. GitHub, thank you. Thanks, Becky. Totally forgot. Now, because I don't know if you know this, but I kind of have a job at Microsoft and I work at GitHub as well. I have like 2 jobs. It's fantastic. We have just added a machine learning and ML ops community discussions area. Community discussions area. Conversations related to machine learning, model development, and ML ops on GitHub. Please review the pinned post for this category's guidelines prior to posting. Read more. Machine learning projects and models are pretty awesome. Yeah. Amen. Turns out a lot of folks happen to put their ML GitHub and even use some of the amazing GitHub features to manage and power their projects. Most of the questions related to this amazing area tended to fall in a sprinkling of different categories, so we thought we would try to consolidate. Can I update yet? No. They're making me an admin of this. So if you have any questions about machine learning and GitHub, etc., look at this. There's so many things in here already. I need to go. Oh, those are all the discussion. Come on over. Put your stuff in here. Ask some questions. Put some models up. If you have something cool, we want to see it. Make sure to go to the communities, GitHub communities. You can see that here. Oh, look, they invited me. Go to discussions on the communities and then hit the machine learning and ML ops community so that all of your questions answered, all of them. And you know what? I told them that because I'm in charge of this, I have to answer the questions. I may write some GPT code to answer regular questions, if you know what I mean. I'm pretty excited about that. So make sure to go to github.com and then hit up the machine learning and ML ops discussion group where we're going to have a ton of fun talking about machine learning and GitHub. Again, another thing that I want to talk about is next week. Next week, we're going to be talking to Sarah Bird about being responsible with large language models, and I'll show off a little bit of my particular project that uses a large language model. So make sure you tune in for that on the AI show next week. Thanks so much for being with us. We always enjoy spending time with you. It always goes by way too fast. Thank you so much for watching, and hopefully we'll see you next time again. Large language models being responsible, a large language model project that I wrote a couple of weeks ago to see how these things work. Love to share my learnings with you. Thank you so much for watching, and hopefully we'll see you next time. Take care until next week.